Okay. So, to celebrate 100 years since Albert Einstein won his Nobel Prize, we're gonna derive his most famous equation. So, first let's think about classical mechanics. The definition of force, as we know, is the derivative of momentum in respect to time, which is minus the derivative of potential energy related to position, right? So we can just put it here, and it becomes that velocity dp equals minus du. Since for classical mechanics the momentum is mass times velocity, we can just write this as dp equals mdv, right? So this becomes mv dv equals minus du. By integrating both sides here, we get that mv squared divided by 2 plus potential energy. This gives us a constant, and this is just conservation of energy, right? This is just conservation of energy, nothing really surprising here. For relativity, everything that I did here, from this part to here, it's valid. So v dp equals minus du. This part here, everything okay. The thing is, for relativity, momentum is gamma mass velocity, which gamma is the Lorentz factor, right? 1 divided by square root of 1 minus v squared divided by c squared. So, by doing some algebra, we have that velocity is pc divided by square root of pc square plus mc square, right? This thing here. So, replacing here, we have that pc divided by square root of pc square plus mc, just p here, p plus mc squared dp. This is just minus du. Put in an integral, therefore we have this thing here. It's a bit different. Let's say sigma, okay? Sigma is p squared plus mc all square. There we have this sigma dp equals 2p. Replacing it, we have dp equals sigma divided by 2p. So we have integral of pc square root of sigma equals this is sigma divided by 2p, right? So we can cut it, and that's just integral of minus du. So by putting the integral, right, we have that c divided by 2 times 2 square root of sigma, which sigma is this thing here. This is just minus u plus a constant. As I showed, this is just the kinetic energy. This way we can assume that this is an internal energy of a body, and this internal energy, by cutting the 2 in the denominator and numerator and just replacing sigma by this thing here, we have that this is the square root of pc square plus mc square all square. And this thing here, this is just energy, the internal energy of a body. And if we consider the body is it's not moving related to a frame of reference, we have that E0 is mc squared, which is Einstein equation, and is probably the most famous equation in history.